Okay guys, making a quick video here. I'm going to try to get through this. This is our next unit, the cell membrane. And first it starts with a little tiny piece of the puzzle called the phospholipid, which is just a tiny piece of the cell membrane. If we're going to zoom in super much on a cell membrane, the tissue that surrounds a cell and kind of allows stuff in. It's what's called a semi-permeable membrane. All right, so if you look at it from kind of a zoomed out perspective, you see these hydrophilic, which means water-loving heads made out of phosphorus, and then these hydrophobic, which means water-not-loving tails, and those are made out of fatty acid chains. If you look at the picture down below, you can even see these big purple blobs all throughout, and those are proteins that allow things to pass in and out of the cell. And the cell membrane allows water to go in and out so that it can stay completely hydrated. A couple of key words as we go through this. One is diffusion and one is osmosis. So diffusion, what are some times that you've witnessed diffusion? You have to think about this for a little bit. You have to key in on exactly what that term means. What does diffusion mean? Diffusion, basically, if I were going to put it in kind of my rudimentary accent, my old school accent, I'd say diffusion can be defined as stuff going where it ain't. So when stuff flows to a place or winds itself up in a place where it isn't, it is diffused. Odor is one thing that diffuses. Pleasant odors and not so pleasant odors. So if you walk in the door and you're not even near the kitchen, but you can go, oh, mom's making chili or dad's barbecuing, that's diffusion. That's that fragrance going where it isn't. And things can diffuse in other ways too. If you just took a spoonful of Kool-Aid powder and put it into a glass, you can turn that whole glass of water purple, and that's diffusion also. There's cream diffusing through coffee. So diffusion is one way that cells uptake what they need by stuff going where it ain't. If cells need something and that something happens to be in greater content on outside of the cell, it will allow it to diffuse across the membrane sometimes very effortlessly. Okay. So on a molecular basis, there's something called Brownian motion that drives it. And basically it's that things aren't going to stay tightly packed. They're going to spread. Okay. So on a molecular basis, things are going to spread out. Okay, with regards to a cell, if you have a cell, here you see a cell membrane and you have a nucleus. If there's a lot of something on the outside or a lot of something on the inside, it's going to go across the membrane by something called diffusion. Okay, cells surround themselves with that selectively permeable membrane, and things are able to go across the cell by a process called diffusion. Now this is something that happens that doesn't require any effort on the cell's part. Diffusion takes place with very little effort. In a little bit, we'll talk about times things go across the lipid bilayer that requires effort on the cell's part. So now, one type of diffusion is osmosis. And osmosis can be defined as diffusion that is specific to water. Okay? So if you look at a solution and on the outside of a cell, and then you look at a solution on the inside of the cell, things will have a tendency to go one way or the other based on their concentration. So this is an example of what's called a hypertonic solution. Okay, there's an awful lot of solutes on one side of the cell. Which side of the cell are the solutes on? To go back, what represents a solute? Then you have to think, what is a solute and what is a solvent? So if we had, for example, Kool-Aid in water, the powder is the solute and the water is the solvent. Okay, in a hypertonic solution, water is going to flow out of the cell because water is always going to flow towards the solutes. All the solutes are outside of the cell, and that is the direction water will flow, causing the cell to shrivel up like a raisin. So I say hypertonic, and that's raisin. Causes the cell to lose turgor pressure. All that water leaves the cell. Kind of like air leaving a tire. It loses pressure. Okay. Now in this case, water is going to flow towards the solutes. There's more solutes inside of the cell. So the cell is going to swell and get big. It's going to increase its turgor pressure. And I'd like to think that as it increases its turgor pressure, it makes it like the letter O. Becomes hypotonic. And it gains turgor pressure. It could even burst. Water always flows towards the solutes if they're on the inside of the cell or if they're on the outside of the cell. If they're on the outside of the cell, it's in a hypertonic solution. And if they're on the inside of the cell, it's in a hypotonic solution. Now, all the solutes are balanced. We have the same amount on both sides. This is equilibrium, also called an isotonic solution. This is the optimal environment for a cell. It has the perfect turgor pressure. That's what a red blood cell should look like down there in the corner. Okay, that's equilibrium. That cell has reached equilibrium, which is the goal of every cell membrane, helping a cell reach equilibrium. Okay. So if water flows into a cell, it increases its turgor pressure. That's normal. Equilibrium. And there's water leaving a cell, maybe a cell that's in salt water. Salt water would be an example of when there's lots of solutes in the water and not very many inside of the cell. Water will leave it. That's why we get dehydrated in salt water. Water leaves us, goes towards the solutes. In plant cells, you can look right here at the vacuole. See that vacuole right there? Okay. Water flowing into it and superhydrating the plant. There's some turgor pressure in there. And then when a water shrivels, or excuse me, a plant shrivels, because it's in a hypertonic situation. That's why leaves wilt. Okay. Okay, so osmosis is just a type of diffusion that's specific to water. So hyper, shrivel like a raisin. Hypo, may bulge out, a lot of turgor pressure. Form the letter O. Isotonic, that's equilibrium. Okay, so a couple of key words. Selectively permeable. That means allowing some things through the cell membrane, but not everything. Okay. Okay, this is kind of part 2, osmosis and diffusion. Okay, so why do we smell pie? When there's pie being made in the house, how come we smell it? Or why can a shark smell blood in the water? They say that a shark can smell a tiny drop of blood in the equivalent of 17 Olympic-sized swim pools. Okay. People can die of carbon monoxide poisoning. Why? Or why did gas warfare work so well in World War I? Okay, the answer is diffusion. These are all examples of diffusion. Okay. What do we call diffusion that is specific to water. Okay? So if you think of a cell's lipid bilayer kind of like a fence, some things can get through easily and some things cannot. Okay? It's a barrier that allows water and some other molecules to pass through freely. There are times water can enter and exit a cell in a hypotonic or hypertonic environment. Cells lose trigger pressure. Okay, so which plant cell is in a hypertonic environment and which plant cell is in a hypotonic environment? Can you figure that one out? Okay, if you look at Kool-Aid, what part of Kool-Aid is the solute? What part of Kool-Aid is the solvent? Put a cube of sugar in water. Pretty soon the whole glass of water will taste sugary because of diffusion, stuff going where it ain't. Now here's something to copy down, the term facilitated diffusion. Okay, what you see here is a picture of a lipid bilayer and a protein that's embedded in the lipid bilayer. That protein is designed, it's kind of like Pac-Man. It's designed to let certain things in the cell or remove things from the cell. Here's some words to write down. Carrier protein, ion channel, solute, solvent, trigger pressure. You could pause this and copy those things down. They're all going to play a role. Okay. What is a concentration gradient? A concentration gradient is when you have lots of something on one side or the other of the cell membrane. So if you put a cell in salt water, you're going to have a high concentration gradient of solutes outside of the cell. If you take a cell and put it in pure water, it's going to have more solutes inside the cell. So the concentration gradient would be inside the cell. Okay, when water flows from an area of high concentration to an area of low concentration, it doesn't require energy for the cell to diffuse those molecules across the lipid bilayer. We're no longer just talking about pulling water across the cell membrane. Now we're talking about pulling solutes across the cell membrane, stuff that a cell might need. And when there's lots of stuff outside of a cell and not much stuff inside of the cell, it's easy for the cell to pull that stuff in. Okay. Much of the transport across the lipid bilayer requires no ATP. That's what's called facilitated transport. Okay. Cells use carrier proteins or ion channels, and this pulls stuff across the lipid bilayer with no effort, no ATP. Okay. And then our next slideshow, we're going to study active transport, which is when cells have to pull stuff across the lipid bilayer using ATP. Like, for example, if there's a whole bunch of stuff in the cell, but yet it still needs more, like something like potassium, for example. Let's say you're in a race and you're running hard and your body still needs more potassium. Pulling that potassium across the lipid bilayer will require ATP, the use of ATP. Okay, so to review real quick, okay, pulling things across the lipid bilayer not using ATP is what's called facilitated diffusion. You don't need to burn any energy when you're going with the concentration gradient. Okay, these guys all play a role. These are important terms to copy down if you haven't yet. All right, concentration gradient is when you have more of stuff on one side or the other of the cell membrane. You're not in equilibrium. Okay. All right. Okay, and then next we'll study active transport.